We are live now. Now we are live. So let me just check. Yes, we are live. Welcome everybody to this 12th webinar, preliminary webinar of our fourth World Congress that will take place from 30th of June to 4th of July. And we are holding a series of preliminary webinars preparatory for the Congress. So today we have Alberto Cavallo talking about data centers in space. And before that, Maria will briefly introduce you, Alberto. Please, Maria, go ahead.
Yes, good evening, everyone. It's a pleasure to be with you tonight. So, the topic tonight is interesting and it will be presented by our speaker, Alberto. The topic is called Data Centers in Space, an update about the topic. So, a central thesis which Space Renaissance International has announced since the beginning is the opportunity of moving industrial and business activities to space, not all space activities like communications, Earth observation, and positioning services, but all industries that have also a significant impact on Earth's environment and can practically be transferred to space, specifically in the cislunar environment. There are several motivations to do that. First of all, reducing land occupation. Second, avoiding emissions of chemicals as well as waste heat on Earth, which affects the use of water, which is a precious resource. Third, reducing the load on energy systems, which in turn affects 1, 2, and 2, 4. 1 and 2 for reason ensuring the possibility of unlimited scale up when space resources start to be used. There is no doubt about the advantages, but in order to reach an industrial development of Earth, several conditions must be met. First condition that can be cited is the activity that must be feasible in space. Second, the product or the service must be easy to deliver on Earth because initially the market will be there. Third, the first activities should not require big technical advancements to be performed in space, allowing a reasonably quick deployment. Four, cost must be competitive. Data centers are good candidates for the role of the first land-based activity that can be moved to space. The paper deals with the advantages and requirements connected to transferring data processing into space, showing how this operation can reach the goals and meet the conditions listed above. The main downside is, of course, the cost, but the amazing progress being achieved in the reduction of launch cost can be decisive and can enable the initiatives that are in fact already starting, as described in the final section. Recently, as in November 2025, the Blue Origin New Glenn Heavy launcher became fully operational with the flawless second launch, while SpaceX Starship has overcome some failures, succeeding in 2 consecutive test launches and is underway to reach operability possibly within 2026. These launchers can reduce the cost to orbit enough to make space-based data processing competitive with land installations. This paper is an update of the one presented at the IAC in 2025 in Sydney with the title 3 times E, Energy Economy Environment, a Space Perspective Case, Big Data Farms in Space. A short bio about our speaker, Alberto Cavallo. Alberto Cavallo is an electrical engineer, graduated from the Politecnico di Torino University in 1985. He began his activity with designing electric systems in Fiat Engineering, the engineering and construction company of the Fiat Group, moving soon to control the automation systems in the same company. He was involved in all business areas of the company, which included revamping and new projects of car factories for the Fiat Group, as well as large infrastructures, power, and cogeneration plants for external clients. Among the projects of the time were the new Fiat factories in Melfi and Prato La Serra, the high-speed railways Torino-Milano and Bologna-Firenze, the district heating system of Torino Sud, combined cycle power plants for several hundred megawatts in Italy and in Brazil. Since Fiat Engineering was transferred from the Fiat Group to a new EPC group and then merged with a large EPC company in Milan, he was involved in large oil and gas and petrochemical projects all over the world until his retirement recently in 2024. Besides his professional activity, he has always taken part in several cultural activities. He was a member of the Association of Alumni of the Liceo Classico Vittorio Aliferi of Turin. He's active in promoting humanistic culture as well as its connection to the technical and scientific area. Alberto manages also his own website, which is www.urinom.it. It's also it's only in Italian, and it shares knowledge about philosophy, science, politics, geopolitics. Due to this, he got in contact with Adriano Ottino and his TDF. Then he became one of the founding members of Space Renaissance International. Besides several papers in his professional area, he has written several articles for his own site, for TDF and SRI, co-authoring the book Three Theses for the Space Renaissance with Adriano Ottino and Patrick Collins. He is currently a member of the board of SRI. Dear Alberto, you have the floor.
Thank you very much, Maria. Thank you, Adriano.
My pleasure.
You have already introduced the topic of this presentation that will be essentially an update of the presentation that I gave last year in 2025 in Sydney for the International Astronautical Congress and Conference. And now I'm going to share my screen. I'll first try to share desktop. Can you see my desktop? Can you see my desktop now?
Yes.
Yes, we can see it.
Okay. So now I'll start the presentation. Okay. Okay, so this is the update about the data centers in space. And first of all, why data centers in space are not just an idea, they are coming. The explosive development of internet services in recent years and the advent of AI is causing, in some areas of the world, a huge impact on energy demand and other things. For several reasons, data centers are one of the most suitable activities to be moved to space. Now it's happening, and we will see later how it's happening. In this presentation, we will see, first of all, some indications about the situation of energy demand in the world, is mostly in the Western world, that are a part of the problem. What are the most critical requirements data centers on Earth and why it makes sense to move them to space? What are the requirements and the difficulties for data centers in space and who has already started to work at this? First of all, electricity demand, and I'm starting from this, of course, it's also my main professional competence. It was, among others, but it was the main one. Global electricity demand is growing, and most of the global growth now is taking place still in China and India and Southeast Asia. And it is mostly due to traditional industry. No, not traditional, to industry, not traditional because it's connected to energy transition. That means PV panel, electric vehicles, batteries there. And this is causing an interesting increase in energy consumption that makes the energy transition more difficult from fossil fuels to new energy sources. But this is another point. In USA and Europe, it's quite different because due to the deindustrialization, energy demand was stagnating or lowering. But now it started growing again due to data centers. Here we see some data. These are the data that I presented last year. Anyway, they are still good. There is a forecast also up to 2027. The data are from 2024. You can see that China and India have both still a very high increment. China is declining has gone down just because the rate of new industrialization in China, of course, is decreasing, while India is keeping constant besides the time of COVID, of course. If you look at the United States and European Union, the situation is much different. And but you can see that a new increase is beginning in the current years nowadays. And this is mostly due, if we go, for instance, to the USA, mostly to data centers and in general other non-industrial users. We can see industry is very low for about the increment, other sources are low, other consumers are low, but data centers cover the majority of the increase in the United States. And now this is growing faster and faster. And this is creating issues, especially locally, due to the fact that, for instance, exactly in the USA, the interconnection of the grid is not so good to nationwide. So essentially, a new large consumer in one place causes problems to all the other users around there. Because data centers have a heavy energy impact. I personally was involved in a proposal a couple of years ago, 3 years ago, about the possibility to build a data center. A typical data center that can be proposed nowadays may be from 132 to 250 megawatt, and this scale is increasing. They are already talking about gigawatt scale. And this is a large impact. To be understood by those who are not so accustomed with these levels of power. This is more than the power of a typical industrial plant, even if it is less than the power of a typical power generation plant. But it's very high. It's very high. Another point about energy transmission. Solar and wind power is intermittent. So it cannot fulfill the requirements of industrial usages and especially data centers. You cannot plan the sun and the wind especially due to the weather, first of all, and the day-night cycle. So solar and wind power is not suitable for data centers unless you have a lot of storage that is not exactly economical, not so much feasible for a long time. The current answer that is going on now for these new data centers is building more and more gas-fired power plants in the US. For instance, in Texas alone, there are 130 new projects for a total of 58 gigawatts. Gas-fired power plants can be built quickly. The natural gas is available in the US because the US is also an exporter. And so in most cases, they are building or restarting power plants of this kind. In the longer run, but also now about restarting existing plants, nuclear power will be the answer, especially with small modular reactors. I was also involved in this business, and I can answer if there are questions about that. Small modular reactors, for sure, are another power source that will be used on Earth for powering data centers. And of course, since here on SRI we also presented these solutions, space-based solar power could be considered, but in the current situation, considering that data centers are in explosive growth, and basically SBSP is only on paper because this is the truth. From the engineering point of view, there is nothing is ready, and maybe I'm convinced that due to SBSP cannot be competitive at least for a couple of decades. This is my opinion, but I have reasons to say that. We can also discuss this later, but this brings us to the main point. But first of all, we speak about the other impacts of data centers. The data centers have the other side of the impact is heat, because essentially all the energy that you put into a data center is then converted into heat. This is a huge amount of heat that must be dissipated. So data centers normally are located near the sea or near large rivers, and they use a lot of water. which is not exactly environmental friendly and also costly. Otherwise, if you have no water, you should use very large air coolers, which much higher cost and much higher complication. So even if you can source power from elsewhere, you charge locally the heat. So the environmental impact is high anyway. Then there is the problem of soil occupation, because we are taking valuable soil in places that are well located for other kind of uses that maybe are more productive from other point of view. And by the way, if you have to add new power plants, you also need the space for this soil occupation of the power plants. So essentially, uh, soil occupation is also important. Therefore, data centers are a good case that highlights the opportunity of moving activities to space instead of moving resources from space to feed activities on Earth. What's happening in space now? Essentially, what's happening is that data generated in space are a huge amount. Data collection in space is growing and growing, and by the way, is one of the first usages of satellites. So satellites generate imagery and data of all kinds concerning from weather to crops to any kind of situation that is visible from space. All these raw data that are in very large quantity must be transmitted to Earth and processed, or we can consider processing them in space. And this has already started, because processing data in space means reducing the amount of data to be transmitted, the raw data. We can transmit the processed data to the ground. And this means that processing power in space is already there, is already being used, and is expanding. So from this, the next step is, why don't we put data centers in space for other usages, not directly connected to space? That means, for instance, we'll see also AI training. So, what are the problems we are going into if you want to put data centers in space? Essentially, the requirements and the criticalities about data centers are here listed, and then we will go deeper into each one. One is energy. In space, of course, solar power is constantly available. Paying attention on the location, we'll see that. Cooling in space, we can use the cosmic background, that is a heat sink at very low temperature, so even if it is only available through radiative cooling. But in any case, cooling can be done in space, and basically these solutions are already studied, already in place at a smaller scale, but they are there. For instance, if you look at the ISS, you can easily see the coolers. Data connection from space to Earth and back is very easy now, because we have internet constellations already there. Starlink is connecting the world, so large part of data connections in the world are already transiting through space. Security basically is improved in space, except for risks connected to space debris. Radiation is a big drawback of space. We will focus on that a little later, but solar and cosmic radiation, of course, can threaten the computers. They can both cause errors and damage the hardware. Latency, I listed it separately because space distances may introduce an additional latency that can impact some applications for data centers. That means that you have to wait more to have your result. Maintainability, of course, is another issue, a very important issue, because, of course, in space, maintenance is more difficult if compared with what we do now. Then we go deeper into this. Energy. In geostationary orbit, solar power is almost constantly available, but there are other issues. Essentially, the problem is that you have one orbit that is slotted and reserved for many other uses, and transmission latency is important. Nearer to Earth, we have the problem that for part of the time, the satellites will be in the shade of the Earth. So a sun-synchronous orbit is the best. Sun-synchronous orbit, as represented in the picture, uh, rotates around near the poles and is always exposed to the sun, because also the orbital plane is always slowly rotating to keep track with the sun. So essentially, this is used nowadays essentially for observation uses. But in this case, also it's very important to have it for constant availability of solar power. The moon is unfavorable for solar energy because unless you are in some very specific places near the poles, you have 14 Earth days of darkness every lunar day or night. That means every month, roughly. So on the moon, nuclear energy is basically the only feasible solution. Lunar Lagrange points instead are favorable solar. If we, apart from the problem of latency, lunar Lagrange points can be good. If large data centers are chosen, there is another drawback, that is the size of the power system. Because solar panels would be huge, which makes collision more likely. But apart that, there is a problem of transporting this electric power from the panels to the processing units. Because this system will become so large that the electrical transmission from the collection system to the consumers on board these huge satellites would require a very complex and electrical system with problems of cost and weight. Therefore, from this point of view, small modular units are to be preferred. For cooling, we have already said that there is the heat sink of cosmic background. Heat must be transferred from the data processing units to the radiators that are placed in the shade, of course. We can use or not use the refrigerator cycles to reduce the size of radiators. On the ESS, if I'm not wrong, they use refrigerator cycles. This is basically a heat pump. But in any case, you need fluid circulation just only for heat transfer to the radiators. And then the radiators radiate energy toward the cosmic background. The choice of solution can be left to a later stage. But again, we have the same problem as for electricity. If a large data center in space would need a large cooling system with very complex systems of radiators and complex systems of refrigerated fluid circulating all over that, over long distances. So again, huge cost, weight issues, complications. So small units are very good also for cooling, not just for energy. The problem of data connection, of course, it's already available as satellite constellations for internet service are already up and running. So we can see that these solutions are technically available. It was impressive how during the tests of the Starship, SpaceX was able to transmit high quality video even during re-entry, during the most difficult phase of the flight. No doubt that it's possible to transmit high volumes of data to and from Earth. And satellite to satellite resonant transmission, and you don't need the cables, of course, in space because you have no attenuation, because there is no atmosphere. It has been tested, is already in use, for instance, by Starlink. And so a constellation of smaller units can have satellites communicating with one another through satellite resonant transmission. That means that giant single data centers can be replaced by a swarm of smaller units. Security. Cybersecurity in space is the same as on Earth, but I wanted to cite it because cybersecurity is always considered in this kind of nowadays is decisive. Security against physical assault is better because, of course, criminals and terrorists cannot reach satellites, but spacefaring nations have anti-satellite weapons. So, in case of a war, a data center in space would be an easy target. We hope that no space war breaks out. Of course, otherwise all our discussions are useless. Natural disasters of Earth are fully avoided. For instance, you have to locate your data center near a big river. If we have a flooding, your data centers gets wet. So in space, this doesn't happen. We will talk about radiation later separately. Space debris are a risk, especially in LEO, of course. A constellation of small satellites will adopt the same precautions used by telecommunication constellations, and with mainly collision avoidance. Large satellites would expose an extended impact area and may be more difficult to maneuver. This means that also for this reason, large satellites, large data centers are not so much advisable. Problem of the radiation. Radiation is very severe for electronics. Solar and cosmic radiation causes errors and may even physically damage circuits. The threat is high, especially during solar storms, of course. But from this point of view, much has been done during the last years. NASA and HPE experimented with the spaceport computer program on board the ISS. Essentially, they put servers on board the ISS, hosting also an AI software by Booz Allen Hamilton. And essentially they did not use special hardened space-rated hardware. Hardware was normal hardware to be used like the one on the Earth, but they only used the software error correction. And they gave good results except for solid-state disks. Experimentation is going on, but in the end is quite promising. It's very important that Star Cloud, and we'll talk about this later, already have in orbit a satellite using an NVIDIA H100 GPU. That is a typical GPU used for AI. It's currently in space, they are testing it. So we will see what are the results about sensitivity to radiation. The problem of latency. Latency is described here because in space there are specific issues. For instance, LEO constellations are now preferred to geostationary because of the delay, because geostationary orbit introduces 240 milliseconds of delay, more than the delays that you already have for all the other parts of the transmission. If we consider the moon, the delay is 2.5 seconds, the additional delay, plus the elaboration time, transmission time for the on the ground, etc. So this is basically it's not acceptable for if you have something that in real time it is used in real time. In fact, lunar locations are now considered only for data storage. You could do some elaboration on the moon, but for instance for AI training, but everything would change only if data are generated on the moon, of course. So basically, we are talking about AI training, data storage, and batch processing of other kinds, and of course, edge computing that must be done in space or must be done on the moon, for instance. Problem of maintenance. Of course, if we use a constellation of small satellites, basically they can operate like all constellations. That means just replacing faulty satellites. If a satellite is faulty, hopefully we can deorbit it and replace it with another one. With a big one, you would need to repair it in space, which means modular design, replaceable subunits, robot maintenance. But I prepared a slide specifically about the future. If we look at the other side, if services are needed for space clients, and this means when space industrialization starts for real, mining or raw materials on the moon and the asteroids, production of materials and goods in space, data processing in space will be needed as a service to space activities. So if an IT service is needed in space, the location of the data centers must be in space because of all the considerations, especially latency and other things. So basically, the idea is that in the future we will have even human crews for that. So we can even perform complex maintenance operations if you have human crews. In the future, when many humans will be living in space, the maintenance problem will become a job opportunity for those people. And this is the point of the concept of bootstrapping a space civilization, finding activities that we can start in space in order to start a space civilization. Data centers in space can be one of the elements of this bootstrap. Now I'm moving to some projects that are ongoing. The first one is a study, just a study by the European Union, the ASCEND study. It is financed by the European Commission for Horizon Europe. It's led by Thales Alenia Space, and there is a large participation in Europe. It has performed an analysis of needs and context. They have already defined the system architecture with all the trade-off and optimization of the architecture. So they have defined what will be the European Space Data Center, and they are now preparing a full feasibility assessment. This is the architecture they are proposing. They have already defined it. So essentially, you can see that it is much like the concept that I talked about earlier. Essentially, you have a processing unit, the ones represented in yellow, surrounded by solar panels represented in blue. And on the back, of course, you have the coolers. This is already a realistic representation. This overall unit with 800 kilowatt of power only weighs 32 tons and can fit in a heavy launcher. Of course, this would be launched all folded and would be assembled in space automatically, like is done with many other space structures. So basically, this is the architecture they are proposing. We don't know if we will see it done for real, but anyway. The US company StarCloud have proposed a large project for data centers in space with the idea of first serving edge computing tasks and then evolving into high-power data centers. Their orientation is essentially towards AI training. This figure is from them. Also already represented the StarCloud 2 satellite, not the final one, but we will see that they are changing their mind on some things. Connected to both in-space assets, to the ground, and to third-party networks that are already there. And they have prepared this table of costs showing that according to their calculations, a data center in space can cost less than data centers on Earth. Provided that if you have a look at the main point, that the second line is the most decisive one. It's true that many things are not required. For instance, no water usage, no backup power supply, because in space you have constant solar power, and you don't need diesel generators for backup power supply. I didn't speak about it earlier. You need some shielding, okay, not required on Earth, but in the end, the main point is the cost of the launch. They considered 5 million in this table, considering that for the new low-cost launchers like SpaceX Starship or maybe New Glenn can fulfill their promises of reducing further the cost of launch. That is the main decisive point. About StarCloud, they initially proposed to reach a very large size. They proposed reaching a size of 5 megawatt power plant with the solar power plant 4 by 4 kilometers. That is quite large. But I already explained that it would cause also issues about the electrical system, and of course it would be vulnerable to space debris. Many problems about that. The, but first of all, in any case, they have been endorsed by NVIDIA. This is a very important point, because with the endorsement by NVIDIA, which is also financing them, it means they are taken very seriously. Now, in October last year, they announced an agreement with Rendezvous Robotics to explore the use of modular autonomous assembly to build the data centers. So they would split the data center into small tiles, each one fully equipped with power, cooling, and processors. So essentially, they are moving towards an architecture like the one that I showed about Ascend. Essentially, they are moving towards modular units and not just a big one with modular units only for processing. No, modular units including power, cooling, data transmission. On the 2nd of November last year, Falcon 9 delivered to orbit the StarCloud 1 prototype. So they already have in the bandwagon for mission, Falcon 9 is often used for these clustered launches with several payloads, different payloads. StarCloud 1 was one of the payloads. And it is equipped with an NVIDIA H100 GPU, which is a typical GPU used for AI training. Of course, for testing how it behaves in space. They are in contact with the satellite, and we will see what happens. They are already testing. We will see how this kind of hardware behaves in space. Lone Star is another US company focusing on the moon. They have sent two demonstrators to the moon. Not very lucky, because they were both on board Intuitive Machines landers, and you know that both landers, the first toppled down, and the other one even worse, toppled down and in a worse way. But they succeeded in testing something. But in the end, now they are planning to move their first systems to the Earth-Moon Lagrange 1 point. So they are abandoning the moon surface for now. Another very important project is the one, Xingshidai, a Chinese data processing satellite constellation, a joint venture of ADA Space and Zhejiang Lab. I don't know exactly how to pronounce in Chinese. Essentially, they are already implementing AI for the usage, not for training. It will be composed of 2,800 satellites, each one capable of 744 TOPS, trillion operations per second. The first batch of 12 satellites is already in orbit. Was launched last year in May. I didn't follow the following launches if they are going on, but in the end, this project is already there. They have already launched the first satellites. So the first data center constellation is now already there, being composed of this satellite by China. I'm citing here also an Italian company, the Orbit, because the Orbit is a good friend of SRI, by the way, because they host our location in Italy, in Fino Bornasco. And their Ion satellite carrier has already delivered more than 100 satellites, and that Ion satellite carrier already has computing power. And now they are pursuing this target of creating intelligence logistics in space, an infrastructure that enables both transport but distributed network of space-based data collection and processing, essentially a competitor of the Chinese one that we have seen before. And this is the big news. because SpaceX is getting ready. After the announcements of StarCloud, Elon Musk commented that he can just scale up Starlink V3 satellites, which has high-speed laser links, as I said before. These satellites are not operative yet because they need the Starship to be launched because they are too big for the Falcon. And recently, Elon Musk merged xAI, his company for the AI, that is the same company, by the way, that owns also the social media X, and the AI bot Grok, into SpaceX. So basically, now it is the same company. This company is there to put in orbit the data centers. And SpaceX has already filed with the FCC. FCC is the Federal Communications Commission that is responsible for licensing satellites in the US. Because why communication? Because of course the Communication Commission is responsible for data for radio frequencies. So that's why they are needed to license communication satellites. And these are computing satellites, but they also have communication for 1 million satellites. It's not a joke, it's 1 million. And in the document submitted to the FCC, it says that part of them will be on a sun-synchronous halo, and the rest on 30-degree inclination orbits. You see here a representation that I took from the video that Scott Manley has prepared, and you can find it on his channel on YouTube. You can see all the simulation he has made. It's not by SpaceX, it's by Scott Manley. You can see how these satellites may look like. The position, of course, because of course they would be much smaller than compared with the Earth. But you can see how they will be located. A big halo, a ring around the sun-synchronous orbit, and a satellite shell around the Earth, of course, to be nearer to the users. The satellites in low orbit at 30 degrees, of course, will be in the shade when they are on the wrong side of the Earth. The other ones will be always exposed to the sun, so they will do most of the processing probably. There is no much explanation, but this is the point. And of course, if you consider the capabilities of the Starship, even launching 1 million satellites is quite feasible. If you, I don't have the correct numbers because they were not declared by SpaceX, but they could, I think that they could launch 1 million satellites in less than 10 years, maybe much less. There are many other competitors. Kepler Space informed that Axiom Space is a customer of theirs. That means Axiom Space, you know, they are working at crewed space stations, commercial space stations that will replace the ISS, and they will host computing services. Jeff Bezos announced at the Italian Tech Week in Turin in October last year that in a decade or no more that we will have giant data centers in space. I will explain, maybe not giant data centers, but maybe constellations, but anyway, this is the concept. And as the owner of Amazon Web Services and Blue Origin, he is in the same position as Elon Musk is. He has not announced yet details of the project, but he has all that is needed to do it. NTT, Ramon Space, Sophia, and other companies have announced other programs for space-based computing power. So it's happening, it's near. It's not something that can happen, may happen in the future. It can happen here. It's happening already, and it can happen to a large scale in the next years, not decades, years, months. So some final considerations. The correct solution for reducing the impact of human activities on Earth is not collecting energy or raw materials in space and bringing them to Earth, but moving impacting activities to space. In space, we can use solar power, we can use materials, we can release waste heat in space, we can release other emissions if we have, without harm for our planet. Data centers have already been singled out as an energy-intensive application that is already having a significant impact, at least at the local scale, not yet at the global scale, but it will happen. And it's beginning to have effect. And then data processing can be moved to space, including especially things like AI training, that is the most the activity with the highest requirements, is something that can be moved to space, infrastructure to space, and we have seen what kind of infrastructures. It's not a hypothesis. Several companies, US and China, are already testing prototypes. You have seen that. So we are starting. So thank you for your attention. I'm ready to take questions. I have several references. I think we may put them also in the comments of YouTube and so on. And so, thank you very much.
Thank you, Alberto. I'm looking at the chat on YouTube. Okay.
Thank you, Alberto. Quite interesting. And we have several questions.
Mm,
So please, Maria, go ahead with the questions from the audience.
okay. So I have a question. First of all, when would space-based solar power be available realistically? Someone from Austin, Texas, asking this question. This is the first
Yes,
one.
this presentation was, of course, not about the space-based solar power.
Yeah.
I don't think that the space-based solar power will be available in a short time for several reasons. Basically, everything has to be developed because all the main components are simply not available yet. And essentially, it would not be competitive unless there are big developments with ground-based power with several kinds. Since I've been involved for decades in the energy business, I can say I don't see space-based solar power, at least maybe I don't, it's very difficult to make a forecast now, but I think a couple of decades before we have for real. But, and then the situation may change so much that it's very difficult to say. But for sure, it's not something that will happen in a short time.
Okay. And the same person wrote after, efforts are being made to protect electronics from radiation. Okay. Okay, I have a question here. What is the impact of Blue Origin's TerraWare, a 6 Tbps space network service that was recently announced? So he wants your opinion about this.
I have no opinion yet about this specific application, but for sure is another application like the ones that I described, because they basically they are doing the same that I described by Chinese are doing, the orbit is doing. So essentially, a multi-purpose satellites will be placed in space with the processing power along with other characteristics. So I expect that the path will that one. So first of all, edge computing, you make data processing in space, and then later also uh, data processing for Earth. That means essentially internet services of various kinds, even cloud services, with the low Earth orbit satellites, and then also AI training. But this is not for this kind of systems. The systems will be mostly used for edge computing. That means elaborating in space the data that are coming from space.
Yeah. Okay. Let me check. Okay, so also another question. Who does the Ascent architecture belong to? The Ascent architecture.
It belongs to the consortium, and the owner is the European Union,
Mm,
because the European Union is the final client of this initiative.
true. Yes, indeed. Someone saying, great presentation, Alberto. Many positive feedback. Okay. Now I have a comment here. I have a small comment correction. You cannot achieve cooling to 2.7 K in Earth's orbit, or indeed anywhere in the galaxy. That's the temperature of intergalactic space within the disk of Milky Way. The effective radiation temperature is 10 to 20 K depending on the location. So it's about the cooling detail.
Okay. I put the temperature of a cosmic, the final cosmic
Yeah.
background. Anyway, it doesn't change anything.
Yeah, definitely. Yeah, just a comment. I have also another one. Will AI computing mega constellations and its unwanted emissions ruin astronomy observations on Earth and EM environments on Leo?
Yes, this is a very important point, and you can see that there are so many satellite constellations proposed now that the number of satellites will be so huge that for sure astronomy from the Earth will be impacted. It's not easy to forecast exactly how much, because, for instance, all these satellites by SpaceX, we don't know if those satellites will be bright or not bright. What maybe there will be provisions to reduce their visibility from Earth. Um, they are already trying that. You know that the new generation of Starlink satellites are less visible, but this will have a huge impact anyway. I think that in the future it will be difficult, not only for these data centers, for everything, because constellations are proposed for many different uses. So the number of satellites is increasing a lot, and this, for sure, this is a big issue. But the only answer is to make satellites as little visible as possible.
Yeah.
Yes, I have heard that they are working on that to make some way the satellite obscure and not reflecting very much. I heard about that. I don't ask me where, but yeah, there is this concept going on, maybe with by SpaceX specifically. I have a consideration to be made about the strategy to have many small units to build data centers in space. I think that there may be a problem because, well, I think everybody knows that the so-called rad-hard electronics exist since more than 30 years. I remember when I was working for, when I had my own software company working for some space companies in Italy, that they were producing electronics for satellites, and they were using rad-hard radiation. Rad-hard is a short sigla to mean components, electronic component resistant to space hard radiations. The problem is that that kind of technology was very, very expensive at that time. That was one of the reasons why all space missions had such a high cost. Okay, there were also other reasons, but one of the reasons was that. So the last tendencies with the mini and micro satellites was to use as much as possible off-the-shelf commercial components, because the philosophy is to make redundant units in order if one unit failed, there are many other units taking the place and working. So I see it maybe a little bit critical to produce millions of small satellites using resistant rad-hard electronics, having electronics on board, because that will contradict the using off-the-shelf low-cost commercial components. So maybe this could be
No, but I already
critical.
said that in the presentation. They are not using rad-hard components. They are using standard components. And
That's it.
StarCloud is using the NVIDIA H100 unit, that is the unit they use in data centers on Earth. They are already there in orbit, and they are testing. But by the way, since 2017, they have tested commercial hardware in space. This is the project by HP, and they have replaced hardening with software provisions because
Okay.
they have improved the error correction. And basically, the other point is that, of course, the life of those components in space will be shorter, probably due to radiation, of course. But they are considering that this is not a big issue because anyway, the life of those satellites will not be considered to be very long. If you
Yeah.
have a swarm of small satellites, you will just replace as they get faulty, they are replaced. Basically they are already they already have this hardware in space. They have tested. They are sending thousands
Yeah.
of satellites
So,
that are not hardened like they were in the past. They're not.
okay.
They are using commercial hardware. They are there. Starlink satellites are not so much hardened. They have some radiation protection, but I don't think they have. They are. That is not something. Basically, they are not using specifically designed hardware because essentially, I think this was a legacy of military projects because the military has other issues.
Yeah.
Because,
So okay,
for
so
instance,
you're saying that they compensate let me say the failure rate of the commercial components with some software.
it's not a failure, it's an error rate. The
Yeah,
main
error
problem
rate.
is error
Error
rate.
rate.
No,
Yes,
the problem
they
is that
compensate with the software system that can tolerate and
if you
adjust the
if you read
errors, something like that.
yes, but they have already done it.
Yeah.
It's a study by HP. And StarCloud has a GPU that is a standard GPU used in data centers. They have put in space. They are testing how it behaves.
Okay, that's fine. But okay, let's also consider that the requirements of a supercomputer are different from the ones. So
No, Adriano.
so no, sorry, I don't see myself anymore. So I was thinking that I had some problems, but I don't. It was
No.
only my camera. I was saying that the requirements of a supercomputing, that is what artificial intelligence use, are different from the ones of a telecommunication satellite like Starlink, that is
Yes,
oriented to transmit, yeah, big data because videos and so on, but not to make the work of a supercomputer. So maybe let me say that electronics on board the data centers will be a little bit more critical with respect the normal Starlink uh,
but
satellites.
not StarCloud has placed data center hardware in space is already there.
Okay. Okay. Okay, I believe
It's already there.
we don't know which kind of test they have done and at what extent they have
They,
tested and so on. So okay, this everything is to be
but also,
demonstrated.
no, the tests done by Hewlett Packard since 2017, they used data center hardware, not, they didn't
Yeah, yeah.
use,
Okay. Okay.
they used the servers. And now, what the StarCloud has put in space is a GPU, exactly the NVIDIA GPUs that are used in data centers for AI.
Excellent. So we are happy. Okay, great.
So if they are, I don't know the results for there. Of course, they are not declaring yet the results, but they are testing exactly this to face the problems that you are raising.
Okay.
So
Okay.
essentially, I don't know exactly the results, but in any case, they are doing that.
Yeah. Okay, that's fine.
That's why Elon Musk now is so confident that they can do what he
Great.
wants to do.
So
I'm also a
sorry,
little worried about.
I jumped in and I see that there are other questions, maybe. Maria?
Yeah, I'm looking at it. Okay, so there's someone who asked, will there be any law regulation needed on this issue? But I'm not sure what issue he is really talking about and at what point of the discussion he put the question. So I think we can drop this. But that's it. That's all I have for now. Yeah.
About the regulations, of course,
Oh,
currently the only
yeah,
no,
sure.
I can say something about the
That's
regulations,
wonderful. Yes. Okay. Yeah.
but essentially you have seen that regulations are at the national level. There is a
Mm-hmm.
licensing system that mostly was put in place for before, at the beginning for radio frequencies, of course, because the radio frequencies are a big problem. But this project by SpaceX is now being considered by the FCC, the Federal Commission of the United States, that has to authorize this system. It's only a proposal by SpaceX, and SpaceX had to explain how they want to manage radio transmission and how and where they want to place their satellites. So they need permission, but from a single country. There is no worldwide authorization. It's a single country authorization. But anyway, these are connected because all these national commissions are work together in the ITU, the International Telecommunication Union. So there is a global coordination at least at this level. So basically, it's like launching a telecommunication satellite.
I have to say that in at COPOS in Vienna the past week, I was there for the scientific and technical subcommittee meeting. There was big discussion about the issue of the so-called dark and quiet sky. So I can testify that astronomers are demanding very much regulations for the proliferation of satellites and the problems that the issues that many satellites cause to the astronomy in general. So there is very much attention on this point from the scientific community in general about that.
Okay. Alberto, if you want to add something about this, but for me, I have no more questions in the chat. I think that's all.
Okay.
Yeah.
Okay.
There are no
So
more questions.
it was really interesting, and
Yeah.
I think we will continue to stay informed about data center in space. It was originally, I think we made this proposal maybe a couple of years ago when the data centers in space were not yet so fashion, let me say. And now we see that they are developing, and that's great. And yeah, of course, I understand that many small satellites with high robotic automation around and so on could be more um, convenient from the financial point of view. But of course, what we would like to see it personally, I would not like to see another history like the telecommunication one. That with the telecommunication satellites, we have a filled orbit of pieces of metal and other materials, and we have increased very much the orbital debris and everything what is in space. And so I wouldn't like to see a similar history for data centers. I would like very much more to see manned factories in space, in orbit, and that would be, of course, possible when the launch cost from Earth will be still lower than today, and the having manned activities to be maybe more convenient and more efficient than fully robotic management. So let me say I keep on cheering for the data centers in space, but I would like very much to see another kind of strategy to take place, to take over, and maybe it will be needed to solve the problems that will arise, because always the reality is more complex and more unexpected than what we can foresee and of our plans in general. So, okay. Oh, perhaps SRI should engage. Oh, Dennis. Hello, Dennis. SRI should engage with the expert group on space situational awareness at Corpus. Yes, of course. We are already talking with those guys, and we are planning to do something in that direction, especially in the frame of our proposal for an 18 SDG to be added to the 17 SDGs of the UN 2030 agenda. So 18 SDG has several goals, including more attention to the space situational awareness and space traffic management. So definitely, yes, we are working on that.
Okay. Wonderful. Okay. I think that's all for the chat.
Okay. So maybe we can close if we don't have other comments, and maybe some final considerations by Alberto. And thank you very much, of course, Alberto, for this lecture. And yeah, we will continue working toward our Congress and having other, let me say, introductory, sorry, introductory webinars to the Congress discussion, when we will have several papers presentation, and at the end we will try, as we always do in our congresses, to make a synthesis of the contributes we had and to produce a final resolution with the number of goals for the next 5 years after the Congress toward 2031. That will be our 5th World Congress. Okay, so let me just say what it will be the next dates. I tell you, everything is on the Space Academy website. So the next one will be Cheryl Gallagher, Current Trends in Advancing Technologies in Space Art and Impacts on Space Art Culture. So that will be very, very interesting with Cheryl Gallagher. She is the Ministry of art for Asgardia Association. Then we will have so this will be the 2 of March, the next webinar. Then we will have the 9 of March, Sabine Heinz, my experience in the space habitat at EMMPOL 21st mission. And then we will have the 16 March at Rick Tomlinson, and so on. Okay, so just go on. Okay, I will put in the chat the link to the calendar so everybody can see it. Okay, it is here. Okay, so what can I say?
Thank you, Alberto.
Thanks, everybody.
My pleasure.
See you next time. Ad Astra.